Stop modeling one, and I'm going to skip the first problem. I'm going to go to problem 2, and we're going to do it basically together so you can see what we're looking for. So all of the problems on this are problems that you're going to need to graph and then come up with the equation from the graph that we're drawing. So it won't be so much I'm going to give you the period, the amplitude, or anything. I'm going to give you like a real-world thing that's happening. And we have to model it using a sinusoidal graph or a cosine graph, depending on the problem.
What's a sinusoidal graph?
Using sine or cosine. But I will specifically you'll see it. You'll know whether you're looking for a cosine or sine in these particular ones. And usually I'll tell you what I want from there. Okay, so I'm skipping to problem 2. So problem 2 says the temperature of a solar heated pool changes throughout a sunny day and is modeled by a trigonometric, or I might say a sinusoidal graph. Same thing. Relation. The temperature ranges from 23 degrees Celsius at 6 a.m. to 29 degrees Celsius 6 p.m. So what I'm going to note really, really quick is we have a low temp and we have a high temp. Now, if it's a trig function, it must keep bouncing back and forth between the high and low. So basically, I'm giving you a range. I'm giving you a range right now that it bounces between 23 and 29. Now, it's also going to specify that we're going to use radians. We will not use radians for all these. And I'll give you a hint. So this says use radians. That means I'm going to use the equation period equals 2 pi over b. Problem number 1, it will say use degrees. What can I replace 2 pi with to turn it into degrees? 360, because I can replace the pi with 180. 2 times 180 is 360. So if it says use degrees, we're going to use the formula period equals 360 over b. So if you look at your answer key and it looks different, make sure that you use the right degree versus radian thing. Okay, so we have this graph that's bouncing between 23 and 29. We're supposed to graph it, and we're supposed to graph it over one 24-hour period. Noting that midnight would be t equals 0. So let's quickly do a graph. I'm sure you're going to be able to draw it just as straight as I am and as quickly.
Does that mean we have to do 2 pi over b equals 24, or 2 pi, or 360 over b equals 24?
We're going to use 2 pi.
Oh, radians.
Yeah, we're going to use the 2 pi version. All right, so we have an x and y axis. We're going to have time kind of along this axis. I probably should have more room. We need to have room for 24 hours. It starts at 0, goes all the way to 24. I highly suggest you don't go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I'm going to do is I'm going to do a tick mark, and I'm going to go 2. Tick mark, 4. If you want to, make sure you have tick marks for everything. You could probably use 6s, honestly. Okay, 6, 8, 10, 12. All of a sudden I have a 14. What does 14 relate to in time? 2 o'clock. It's not a fortnight.
14 days is 2 weeks. That's a fortnight.
That's true. That's a fortnight. But 1400 hours, or 14 stands for 2 p.m. 2 p.m. So we're going to keep going up. I'm at 2 p.m. Then I'm at 16, 18, 20, 22. Oh, look at that.
That's a bad 4.
Doesn't get much better than that. How's it a bad 4? Just because it looks like a Y?
Yeah, it doesn't have a 4. 2 Y. 2 Y.
I can't erase on the iPad, though.
29?
We're going up to 24. Because it's 24 hour. All right. Then we're going to have to go. Now pay attention to speed things up. I have to go between 23 and 29. There's no reason I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 23 and 29, because then I'll be trapped in kind of up here land. We're going to do a break, and a good way to do a break is just do a double line. Some people do a little squiggly mark. I'm going to use the double line, which means I'm breaking. I'm not starting at 0, 1. I'm going to skip right to my lower range, which is 23. So I'm going to go, okay, this is 23. Now all I have to do is get up to 29 by counting by, or 9. So 23, 24, 25, 26, 27, 28, 29. Cool. All right. Now, look at this graph. If you were going along for me on this journey where we kind of draw our minimum and maximum, we know that this graph will somehow bounce between these two values.
26 is sinusoidal.
So 26 would be our sinusoidal axis. We should always look at where our sinusoidal axis would be. And I don't even need to have a graph to find the sinusoidal axis. All I need to know is our max value and our low value. That's 6 apart. So your sinusoidal axis is going to be 3 away. It's kind of that midpoint of this value. So to get from 23 to 26 is 6 units. So to get halfway would be counting up 3 units. My sinusoidal axis would go through this point right here, which is 26. So I'm going to go ahead and I'm going to draw my sinusoidal axis.
Where you get the 26 from? Midpoint of 29. Oh, yes.
Use a little magic. Yeah, it's the midpoint of our range. So if you ever know your range and how far it is, your midpoint's halfway through. That's how we're going to get that value. All right, now this graph somehow bounces between all of these. Well, I can already know the amplitude. I don't even need a graph. I can see amplitude. I can see shifting up or down just from that sinusoidal axis. So our amplitude, and we'll do it again later. So our amplitude should be 3, and this should be shifted up 26, which would be our D value, but which we'll cover that in a second. All right, let's post the highest place and the lowest. So at 6 a.m., it's at 23. At 6 a.m., it's 23. So we should go ahead up 6 and put a point there. Got it. Then we're going to go to 6 p.m., which is going to actually be 1800 hours. And there we're going to be at the tallest our graph will get is up here. Now, we could be as accurate or inaccurate as we kind of want for this middle point. I'm going to be pretty accurate on it. I'm going to say, okay, from 6 a.m. to 6 p.m. is 12 hours. So half of that would be 6 hours away. So if I go 6 hours from here, 1, 2, 3, 4, 5, 6, we're at 12. That's going to be where it hits the sinusoidal axis. So at 12, it's going to hit the sinusoidal axis. And now we can kind of see what's going to happen here. It's going to go up, but then it needs to come back down. This needs to go back up here. Well, every 6 hours, there should be a point. So from 6 to 12, there's a point. From 12 to 6, there's a point. So from 6 to, it'd be 24, there'll be back to the sinusoidal axis. And if I count 6 from 6 a.m. at 12 o'clock, we'd be right. Or at midnight, we'd be right there. Is that a sine graph or a cosine graph? It's a sine. It's a negative sign. Thanks for pointing that out. It has to be negative. So we know at the end, our graph should have a negative out front. Let's talk about the information I can pull from this graph. So the first bit of information I already talked about is amplitude. Our amplitude should be 3 because our amplitude is 3 there. It should be 3 up here. So that's going to be my A value. We should be a negative 3 when we're doing our equation. Now the next thing I'm going to point is the sinusoidal axis. How high did I shift that? 26. That's plus 26. That is that D value. So that's at the very end. So we already got the first letter and we have the last letter.
We know that it didn't shift right or left.
How do we know it didn't shift left or right?
Because it's right on the axis.
Because it's right on that vertical axis, that y-axis. If it stays on this axis, it didn't shift left or right. So you're going to know it's going to shift 0. So that C value is 0, or you just don't put it. So the last thing we need to do is just get the period. Now, I'm always going to, when I'm dealing with period, write this equation. I'm going to say, you know what? Period equals 2 pi over b. If you give me b, I can put it in there and get the period. If you give me the period, I can put it on the other side and I can get the b value. If you are given a graph or information, that must mean you're given the period and you have to find your b value. So we have to know how long it takes to do one full cycle. Well, it takes a day. It takes 24 hours. So our period is 24 to get from start to end takes 24 hours. So our period is 24 which is going to give us 24 equals 2 pi over b. I don't care how much work you need to do to solve this. If you just know the answer by looking at it, awesome. If you don't, it's easy enough. Multiply both sides by b. You're going to have b equals 24. Oh, b times 24 equals 2 pi. Divide both sides by 24. You'll have b equals 2 pi over 24, which would be pi over 12. That is your b value. We found our a value, our d value, our b value. It is your job now, and the c value, because it doesn't shift. It is your job now to write the equation. So that is what that homework's going to be. So anyone that's just like ready for the test, you did all your homeworks and stuff, you can just start working on this if you want to, if you want to get a jump start on it. If you aren't